Hello everybody, this is the notes for section 3.2 for advanced geometry. In the first section of chapter 3, and even a little bit before that when we were doing the compasses, we constructed the parallel lines being cut by a transversal. So really, again, the transversal is just a line that crosses other lines. So we talked about some special pairs of angles. We talked about corresponding angles, alternate interior angles, consecutive interior angles, and alternate exterior angles. It's just angles that are, when you have two lines being cut by a transversal, certain ones just kind of match up there with those relationships of corresponding, alternate interior, that kind of stuff. So what we're talking about today is the relationship between those angles. All right, if you want to mess with this drawing, there'll be a link that you can copy down. I'll try to put it onto my site so you can just click on it, but there'll be a link you can copy on one of the slides coming up. So what we have in this picture is the two lines, the horizontalish ones, line CH and line AB. Those lines are parallel. No matter where I move the lines, how I move points A, B, doesn't really matter if I move them this way, doesn't matter. They're always staying parallel to each other. Line DE is the not horizontal one. This line, that's the transversal. So I have each of the four main angles at the intersection of the transversal and the two parallel lines. I have them all measured out with their measurements listed here. So what I want you to look at is, look at those relationships. Look at your corresponding angles. Look at your alternate interior angles, alternate exterior angles, those consecutive interior angles. As I move these things around, here that didn't even change the angle measurements, but as I move these points around, take a look at those pairs. What do you start to notice? Okay, look at your alternate interior angles. This angle here and this one with the cursor. The 125.83 and then this one, 125.83. There's your alternate interior angles. Right now they're equal. So when I move this around, angles change, but they're remaining equal. Okay? As I move the transversal around, still alternate interior angles are congruent. The 75.58, those two, those alternate interior angles, they're always going to be congruent. Look at your corresponding angles. Look at your alternate exterior angles. The 104.42. And the same thing up there. Okay, they're all equal to each other. So that is the gist of this. Now the consecutive interior angles, the whole idea of those, you come in one parallel line, hit the transversal, go down the transversal to the other parallel line, and head back out. When you do this little loop, those are your consecutive interior angles. Okay, consecutive, one after another, both on the interior of the parallel lines. Look at those two angles. They are supplementary to each other. And it doesn't really matter where I move the parallel lines or move the transversal. Supplementary to each other. Okay? So, section 3.2, using parallel lines. Making conjectures we did. Here's that link that I had told you about if you wanted to go to that drawing and just mess with it on your own. Okay, so corresponding angles postulate says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are, and looking at that drawing, they are congruent to each other. If you want to write the word or write the symbol, I don't care. Alternate interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles, they were congruent to each other. Okay, notice the format of each of these statements. It's that if-then thing that we talked about with that logic stuff. The if part, that is your setup. If you have these things in place, then what do you know from that? So the third one, alternate exterior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles, those were congruent as well. Consecutive interior angles. If two parallel lines are cut by a transversal, notice how they're all starting the same, then the pairs of consecutive interior angles are, these were the ones that were supplementary. All right, so some examples that go with this. Really what you're doing is identifying. I am looking at these two angles. They are, well, in number 17, the first example, this 80 degrees and this x plus 15, those are alternate interior angles. Again, the setup, if you have parallel lines, two parallel lines cut by a transversal, we have that situation. Parallel lines cut by a transversal, these angles are congruent to each other. So our setup is the x plus 15 angle equals the 80 degree angle. So x is going to be, subtract your 15, 65. All right, in question number 18, the second example, if two lines are parallel and being cut by a transversal, we have that such situation. Then these two angles, they're on the same side of the transversal, they're both in between the parallel lines. These are consecutive interior angles. These are supplementary. So when you go 2x plus the 68, you should get the 180. There's your setup. The algebra is simple. I'll let you finish that. Looking at number 19, parallel lines. Okay, we're looking at this little symbol right there. That's your parallel lines. We've got a transversal. These two angles that we're given information about, they are on the exterior of the parallel lines. They're on alternate sides of that transversal. These are alternate exterior angles. They are equal because the lines are parallel. So there's your setup for that one. And again, you can finish the algebra. In the last example here, at the same time, everybody, these angles are good, supplementary. It's crazy, I could hear you. Or, these aren't supplementary, sorry, I said it wrong. These are corresponding angles. Maybe I didn't hear you very well. So the 3x and 120 are the same. Okay, those are corresponding angles. Sorry, I messed that up. Okay, so it says warm-ups here, but we can go through these. So now, you look at these problems, and we've done some problems like this before, where you got some angles with different variables. So look for the easiest setup. There's always other ways you can set this up, but you might be creating a situation where you have to deal with systems of equations. If you don't need to, don't. Look for other relationships. So looking at this first example, we got our parallel lines. We know the 110, the y minus 28. We know those two are supplementary to each other. These are linear pairs right there. So to solve for y minus 28 plus the 110 equals 180. We can solve for y. The other relationship we have is corresponding angles. This 110 and the 5x plus 15. Those are corresponding angles. That means they're equal. So the 110 equals 5x plus 15. And so now we can just solve for x. We didn't have to do any kind of relationship between x and y in the same equation. We just had different equations. All right, so now looking at question number 14. In this example, looking at this line here, the 4y minus 16 and the 68. Those are linear pairs, so they're supplementary to each other. So when we add them up, we get 180. So we can solve for y, that's no big deal. Now, the other relationship here is alternate exterior angles. This 4y minus 16 and the 2x minus 24. Those are alternate exterior angles. They are equal to each other. Now, we are going to set this up as 4y minus 16 equals 2x minus 24, where you really can't solve for x or for y in this one equation. But luckily, up above, we were able to solve for y. We'll get a number for y. We're going to plug that in. Now we just have the equation with just the x value in it. We can solve for x. All right. Number 15, same idea. I'll let you do that one. But you're just looking for those relationships. Look for the alternate exterior angles. Look for the alternate interior angles, corresponding angles, consecutive interior angles. Look for those relationships. So that's where the equation is going to come from so that you can set it up and solve for it. That is all. I hope you have a great night, and I will see you in class tomorrow.